let's take a look at how do we solve questions involving factor theorem. Now, we know what factor theorem is. Factor theorem simply states that if px is a polynomial of degree greater than or equal to 1, and if a is any real number, then if the remainder is 0, then x minus a, this must be a factor of px, right? And similarly, if it is given that x minus a is indeed a factor, then the remainder must be equal to 0. Now let's take a look at some questions and how we can solve them using factor theorem. So let's write a polynomial here. So let's say we have something like, for example, maybe x squared plus 3x plus 2. Let's say this is a polynomial and we want to factorize this polynomial. Now, very quickly, what do we mean by factorizing? So let's take a simple example here. Let's say we want to factorize the number 14. So what it simply means is we want to break it into two smaller numbers, which when we multiply, we will get 14. So we can say 2 and 7. So when we multiply 2 times 7, we get 14. Or we can say simply 1 and 14. When we multiply, we get 14, right? So here, we want to break this number into two factors, right? So when we multiply, we get this polynomial. So in this case, we will say, let's say the two factors are x minus a and x minus b, where both a and b are real numbers. Now, why didn't we put another parenthesis here? Or in other words, let's do it. So why didn't we write this as times x minus c? Well, the reason we did not do that is hypothetically, if we had done it, so what would happen is, let's say if we were to multiply these two parentheses, what would we get, right? So we will get something like x squared plus something, 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 and then times x minus c, right? And then when we multiply these two, we will get x cubed plus something, right? So then the degree of our polynomial, the resultant polynomial, will be a cube. But we are given that the degree is 2. It cannot be 3. That means there can be only 2 linear polynomials, right? So let's clear this up a little bit. I think let's do it one more time over here. So our polynomial which is given is px, and it is given as x squared plus 3x plus 2. So the question is, how can we find out the two factors? We are trying to find out these two factors of our given polynomial px, right? So now, if we were to do this multiplication, what will we get? Well, we will get an x squared term, then we will get minus ax minus bx plus ab, right? Now, if you look at this term ab, this is a constant term. And in our question, we should write this as 3. In our question, this is the constant term. That means a times b is 2. So we are trying to find out a and b. Now, ab is 2. So if we can find out all the factors of ab, that will basically give us, if you find out the two factors of ab, that will give us a and b, right? So what are all the factors? And remember, when we try to find the factors, we have to take into account their signs, right? So AB, so number 2 will have only two factors, the number 1 and the 2. But we can have plus minus 1 and we can have plus minus 2. In other words, we can actually have a combination of 1 times 2, right? Or we can have minus 1 times minus 2, right? So now, how do we find out which are the right factors? This is where we are going to use the factor theorem. Because factor theorem tells us that if we find out the remainder at each of these values, there are 4 values. So if we find out p of 1, p of minus 1, p of 2, and p of minus 2. If we find out these, and wherever, if we get a 0, if any one of them, we don't know which one is it. Right now, these are all question mark, right? We don't know. But if any one of them is 0, that means the remainder is 0. That means that will give us the factor, right? So let's go ahead and find out the value of the polynomial at each of these 4 values. So let's start with P1. So if we do P1, we get 1 square. So here, let's do it here. 1 square plus 3 times 1 plus the number 2, right? Or in other words, we get 1 square is 1, 3 ones are 1 plus 2, or this will be simply 6, which is not equal to 0. So this did not help. How about minus 1? If we do minus 1, right? So let's find out. So we have minus 1 square plus 3 times minus 1 plus 2. Now minus 1 square is plus 1. Minus 1 times minus 1. 3 times minus 1 is minus 3 plus 2. So here we have 1 plus 2. 3 minus 3 is 0. So indeed we have found out that this term is 0. So similarly, we will see that if we do minus 2, I have not done the polynomial at 2, and you can do that. But if you do minus 2, what we will find out is if you do this square, which is x squared plus 3x, so 3 minus 2 plus 2, which is this 2 over here. So minus 2 times minus 2 is plus 4. 3 2s are 6, but minus 6 plus 2. So what we have is we have 6, 4 plus 2 is 6 minus 6, 0. So we see that P minus 1 is 0 and P minus 2 is 0. So we can say that x minus 1 and x minus 2. So we can say that these are the 2 factors, or in other words, simply x plus 1 times x plus 2. So we can break this polynomial into 2 factors. So we can say px equals these. These are the 2 factors. So this is how we use factor theorem to solve questions. So let's take a look at maybe one more example. Let's say this time our polynomial px is something like maybe let's say x, how about x squared minus 5x, right, plus 6. Let's say this is our polynomial and we want to break it into 2 factors. So we want to find out x minus a times x minus b. So we want to find out these 2 factors for our polynomial. How can we factor as our polynomial? So again, now this time when we expand it, right, so we will again get the x squared, I should write it as ax over here, minus bx and plus the ab term, right? Let's actually write it again over here. So essentially this will be simply x squared minus ax minus bx plus ab. So the ab term here is 6. That means we want to find out a times b is 6. So if we can find out the factors, the 2 factors for 6, that will give us a, b, right? A times b. So we can find out the 2 factors. So what are all the factors of the number 6? Well, we know the factors of number 6, they are 1, 2, 3, and the number 6. And again, we have to consider the signs, right? So there are 4, and for each value there are 2, plus and minus. So there are total 8 values. So now using factor theorem, so what we need to do is now we need to find out these values, right? So polynomial at 1, polynomial at minus 1, polynomial at 2, polynomial at minus 2, and similarly for 3 and minus 3 and 6 and minus 6. So let's quickly find out polynomial at 1. So when we do that, we get, so we have 1 squared minus 5 times 1 plus 6. So we get 1 plus 6 minus 5. So this is not equal to 0. What about minus 1? So let's say, so we have minus 1 squared minus 5x. So x is minus 1 plus 6. Minus 1 is 1. And this will be plus 5. And then plus 6. So this is again not equal to 0. What about plus 2? So the value of polynomial at plus 2 will be 2 squared minus 5 times 2 plus 6, right? So this will be 4. So this will be 4 minus 10 plus 6. So 4 plus 6 is 10, minus 10 is 0. So we have found out our first factor, which is 2 over here. What about minus 2? Now we know that if one of the factors is 2, the other factor cannot be minus 2, right? Because we are trying to break 6 into 2 numbers, right? So the first number, if we find that to be 2, then the other number has to be 3, right? So we will save a little bit time. So let's get to P3 and see what we get. So when we do this, so we have 3 squared minus 5x. So minus 5 times 3 plus 6. So 3 times 3 is 9. This will be minus 15. And this will be 6. So 9 plus 6 is 15. 15 minus 15 is 0. So our two factors are 2 and 3. That means we can write our polynomial px. The two factors of polynomial are x minus, if it is 2, so it is x minus a. A is 2. We have to be very careful about the signs. So it's x minus a, and this is a. So a is 2. So our factors are x minus 2 and x minus 3. So this is how we use factor theorems to solve these questions that involve factorizing polynomials.